All right, so let's go through some more examples, and that will be the end of this section. So let's try this example. The function is 4 plus 8x minus 5x squared. Okay, so this is a polynomial function. And let's try to find its derivative function. Not just at some point A, it's just more general. So this x could be any input, any value. All right, so let's see what we can do. The derivative, we know that. All right, it's a limit. Okay, h goes to 0, fx plus h minus fx over what? H, right? This is how we define the derivative of the function for some value x. Now let's plug in what do we know about the function. So the function is given by this. If you plug in x plus h, that means you have 4 plus 8 x plus h minus 5 x plus h squared, right? This is fx plus h minus fx. Fx is just that, divided by h. All right? Now, it seems complicated, but if you take the square and so on, you will see a lot of things can cancel. So you have this, just take the product, 4 plus 8x plus 8h minus 5 times x squared plus 2xh plus h squared, right? Minus 4 minus 8x plus 5x squared. So be careful about the sign, right? Because you have minus here with a, so it's minus the whole thing. That means you have negative 4 and negative 8x, but you get, for 5x squared, you get 2 minus signs. That means you have a positive. So that's why you have plus 5x squared. All right. So that's a numerator. And let's try the denominator, which is just h. Now you can do something further. You can cancel 4 with this, with this minus 4. 8x minus 8x. All right. And you can also see you have 5x squared. Now here you have negative 5x squared. So this x squared is also gone. Then you have 8h minus 10xh minus 5h squared over h. All right, so I think you should go through this, just work the whole thing out, right, step by step, and make sure you can get every step, and then you know how to do that. So all three terms on the numerator has h, so you can take out this h and divide it by h. Okay, and h can cancel. You have limit h goes to 0, 8 minus 10x minus 5h. So the limit is h goes to 0, right? So 5h will go to 0 because h goes to 0. 5 times that will still be 0. So what you do, just get 8 minus 10x, sorry. All right, this is a derivative of the function for any x input. Okay, that one is like that. Now, let's try another derivative. Let's try to have second order derivative, f prime prime x. F prime prime x means after you get the derivative, you take another derivative. All right, so this one is, remember we have the notation. This is d, This is f prime x, right? You take the derivative first, which is up here. Then you take another derivative, like you take another prime. Or you can write d dx f prime x if you want. All right, so that means you get the derivative, then you take another derivative. So this is the second order derivative. Another notation for that, you can just do d dx, right? This is first order derivative. Now for second order, you just write d squared dx squared, like that. All right? So that means this is a second order derivative. It's just like you have a d, you do this twice, you have dx, you do the same thing twice, so that's why you have that. Okay, so this is just a notation. Second order derivative here or here. That means after you get this, after you get the first order derivative, you take another derivative. So it could be a little bit confusing, but let's see how we get something like that. Right? You just do h goes to 0. Right? Then you take whatever function you want to take derivative. And in this case, it's already the derivative of f. So it's f prime minus f prime x over h. Okay, so here you have to think about this very carefully. F prime is the function you want to take derivative. So you just, from the definition, you simply plug in this function f prime, but for x plus h, minus this function at x. So that's f prime x plus h minus f prime x over h. And f prime we already know, it's 8 minus 10x. It's right here. So what you do is you just do 8 minus 10, but it's x plus h for the first term. So it's x plus h minus f prime x, and that's just 8 minus 10x. All right, now you can do the cancellations. So I have 8 minus 10x plus, minus 10h minus 8 plus 10x over h. Right, you take out all the product and so on. So you can cancel 8 with that, 10x. So what you get is negative 10h over h, and h will cancel. You just have negative 10. So it's just negative 10. All right, this is the second order derivative of this function. It's negative 10. All right, now that's first example. Second example, let's try to go the other way. Let's say I have the derivative. How do I get the original function? Just by looking at the form, right? So it's just you go the other way. You go from, instead of going from fx to f prime, you go from f prime to f. Find fx and a, given that f prime 2 is equal to limit h goes to 0, 2 plus h to the fourth minus 16 over h. All right, so this is the derivative. You know this derivative at 2. So a should be equal to 2, right? Let's do the comparison. F prime x is equal to, f prime a is equal to limit h goes to 0, f x plus a plus h minus fa over h, right? This is the definition for derivative. Now you try to match these two. So you can see that a is equal to 2. And 16 should be fa. And that one should be fa plus h. Right? So you can see that fa plus h is 2 plus h to the 4th. And a is equal to 2. So what you have here is essentially a plus h to the 4th. So that means for this input, I simply raise this input to power 4. Right? So the function should be x to the 4th. All right? And if fx equals to x to the 4th, now this 16 right here should be equal to fa, right? And a equals 2, so that should be f2. And f2 is, we raise 2 to a power of 4. So 2 to the 4 is 16. So everything works out. All right? So the original function is fx equals x to the 4. And we try to evaluate this derivative at a being 2. Okay? And you will get